So hello, good morning everyone. My name is Francesco. Welcome to the second day of this winter school. So today we are going to talk about a bit of Python and core concepts, file handling and pandas. So we will see what are these kind of concepts. So a bit of me, I'm a PhD student at the University of Trento. I'm studying currently, I'm working on multimodal AI models. So basically Gemini is a multimodal model. That means that you can have multiple inputs that are not just text, but you can have also images, videos, audio, and then you process it and then you have an output. For example, Nano Banana generates images while Gemini generates just text. But you will see this at the end of this winter school. My background is in computer science, so I hope that I don't use too much terminology that you cannot understand, so please let me know and I will simplify it. Okay, so what we will cover today, so I would like to briefly recap yesterday's session, just to be all aligned in order to see the general concept of yesterday. Then we will see the control flow in Python, so how to deal with if-else statement or loop that are the basic programming statement for the Python programming. And then we will see data structures again. Yesterday you saw tuple and lists and dictionaries maybe. So, but we will take again just to see it again. And then we have a general introduction to datasets and pandas. Then I will try to give you some tips and tricks to find datasets for your projects, for your research activities. And then we will try to see a workflow, so an end-to-end workflow to get the data, load it, manipulate the data, and then save it again. And then how to use LLMs in your research work. But yeah, let's start with general information about me. So I'm open to chat during these days, so feel free to ask me. Some steps could be repetitive, but it takes time to improve it, to take knowledge of Python and all the ecosystem. I will try during these slides to give you some tips and tricks for the real-world application in order to be like faster and to use properly the system. And I will try to interleave between theory and practice. So you will be using also Colab today. So I hope that you have the laptop with you and with the connection. And yeah, Python programming is not easy for beginners, especially. So it takes time to master it, but I mean, practice makes perfect. So let's see. And as Franco said yesterday, so learning Python could be a bit boring, but it's necessary to you to speed up your workflow and to large scale your application. Okay, any questions so far? Cool. Okay, so we can do a brief recap of yesterday. So yesterday you saw that text is the main data that we have in the world, and to be able to process this data, we need to automate this kind of application. So the AI in this case helps us to automate this kind of system. And it helps us to detect patterns inside text automatically. So humans define only what we want in output and define what is the input and what is the output. And then AI basically try to map between the input that you have and the output. So it tries to make a connection between the input that you have and the output and try to find a pattern between them. So the method evolution is kind of, we had at the beginning word counts. then rule-based system, then machine learning system that you saw yesterday with Franco, and then currently we have state-of-the-art LLMs models that are very powerful to understand any kind of input. Because as we saw before, they can process also images, videos, audio, so they are very powerful. A brief recap on the workflow, general workflow that AI has. So generally we have data collection. So we collect our data, we scrape it from internet, we download the data set, we have a data set from a friend, from a colleague. Then we have data processing, because we need to, in some way, investigate what are the data and how to clean it, how to prepare them to be good for our model. Because if we give bad data, we have bad outputs. So we need to be sure that these data are well done. Then we have model design and model evaluation. But for now on, we will focus on data collection. So data collection is basically what I said before. So you collect a data set that you want, a data, and you can use publicly available data set. We will see some of them. I collect, for example, Kaggle is very useful for social science data set that you can use daily. And also I found this Pew Research Center that this seems to be, to me, a good resource for data sets in general. So we will see it during this day. Then we have data processing. Data processing is what we said before. So you need to understand your data. You need to be able to manipulate your data set in order to know what you have and what you give to your model. So if you input garbage, you have garbage out. So we don't want this. We want a reliable way to clean the data. For example, remove links, remove bad words, remove toxic words, stuff like that, in order that our machine model doesn't learn this kind of mapping. And so we have an output that relies a bit about, so it mimic our data. Okay. So far? Yeah?
I have a little theoretical question.
Yeah.
Relevant is you have to answer, but I'm interested because the text is very central to this whole thing. But within social sciences, there's a lot of conceptual discussion what the text is and how we should understand that. Hermeneutics, discourse analysis, and various other fields, they discuss what text means actually. So do we have such theoretical reflections within the field, like in terms of how they understand text, what conception of text they have?
I mean, I don't have a specific answer, so I don't have a precise answer to this, because I have a background in computer science, so I don't know a lot of social science. But in this case, I mean, when we try to train models, we need to have a data set that is not that it has diversity inside. So in this case, I mean, depends on your task. Yeah. So I don't have a precise question. Maybe we can talk later. But yeah. So we don't care a lot about. So maybe what we care about is what kind of task that we want to achieve, that we want to solve, and then we choose the correct data. So, yeah. Okay. Sorry, just drink a bit. Okay. So now we will see Python core concepts that are basically the basic stuff that you need to know to program in Python. So, control flow. What is control flow? Control flow defines the dynamic of our program. So, what is execute. So as you saw yesterday with Franco, you can write code inside cells, right? So you can also like create a different flow of your program, decide when to use a specific function, when to use a specific variable, what to do with a function. So it helps you to create your own workflow by writing in Python language. So there are two main flows that I want to present you today that are the if-else statement and the for loop, but we'll go deep now. So we start with the if-else statement. If-else, it helps you to make decision based on a Boolean expression. Boolean means only true or false. So if this condition is true, so if the score, that is the variable, okay, score is a variable, is greater or equal to 60, we execute this. Otherwise, else, we execute this. That's easy, right? So to create a condition here, you have this operation that tells you how to condition these two elements of your program. So the logical operator can be equal, so it means that the one item on the left should be equal to the item on the right. Minus if the item is lower than the other item, greater. And then we have and or, but we don't see it. It's just for you, just to that you know that they exist. How to write this kind of code? So indentation is really important. So indentation, how do you do indentation on your laptop? We will see it later. But basically, you don't need to use braces. So indentation means that you move the position of your code to the right. And that means that this block of execution is done only if this condition is true. Okay? So everything that you put inside here, it's like doing this. Everything that you put here is executed only if this is true. Otherwise, this is the execution. Okay? So it's basically a you decide where to go. Okay? Then there is the for loop. The for loop means that you repeat actions with a predefined, with a fixed number of iteration. So it helps you to count, to aggregate, to loop, for example, inside the list. So yesterday you saw the list. We will see it again. But basically you can loop inside the list, so you can move from the first element of your list to the last one. And this helps us to make repetitive stuff without writing it manually. So the key idea is that, for example, we have range, that is this function that has been already done by someone else, that takes an input free argument. So the first one is where to start our loop. So the first element indicates when to start. The last element indicates when to stop. So after 10 iterations, we have to stop. But this is excluded. So keep in mind this. So we don't reach 10, but we reach 9. Okay? And these are the steps. So how many times, every time we loop inside the this list, exactly, we have a step of 2. So we do 0, 2, 4, 6, 8. If I put 3, it's 0, 3, 6, 9. So it's like jumping 2 by 2 or 1 by 1. So if we put 1, we do all the iteration. So 0, 1, 2, 3, 4, 5, 6.
What does 10 indicate there?
This one?
Do we repeat process 10 times?
Yeah, exactly. But it's excluded. So it means that we don't reach 10, we reach 9. Because we start from 0, so it's basically 10, right? But this is excluded. This is important because people usually think that they reach 10, but in some cases, you don't reach 10. So you expect something, but it's not what you are expecting. So be careful of this. Okay, then we have a brief recap of what are the data structure. So yesterday you saw with Franco, lists, dictionaries, and tuple, if I don't mistake. So what is a data structure, just to repeat it? It's a way to organize your data inside your Python programming. It is a way to efficiently save data, and you have a way to retrieve data, to store data, to move data inside your Python code. The main Python structure that I want to share with you today are the list, the dict, and the data frame. But the data frame is something that we see later on. We will now focus on list and dict that you saw already yesterday. So a list, we can start from the list. A list is a set of elements that you can store by appending them. We will see in the Google Colab how to do it. But basically what you do is to store data in an ordered list. That means that this has position 0, because in computer science, we start from 0 as a position. So this is index 0, then index 1 and 2. And how do you define a list? You use the bracket, the square brackets. Okay, first position, I already said it. And important thing is that it is ordered. So you know how the data are stored. So they are stored in order. They can change. So you can change, for example, index 1, index 0. And you can add different type of objects. So you can add, for example, numbers. You can add string. You can add, I don't know, floats. Yeah.
I'm sorry if this is a ridiculous question. I just wanted to ask, yesterday we had my underscore list, my underscore whatnot, but here we don't have an underscore. Does it make a difference?
So it's just a convention. So the important thing is that you don't put a white space between the variables. So it's really important that you don't use white space for variables, but also for files. We will see it later on. But yeah, I mean, for convention, usually you use, every language has its own convention between programmers. But you can, if as long as you use something that makes sense, it's not X, Z, it's fine. Yeah.
It's a variable name, right? The variable name.
Yeah, exactly. It's a variable name. Mm-hmm. Please.
So in the previous slide, you exemplified this data structure list with list of interview transcription.
Yes.
Can you be a bit more specific about what you mean by this, by giving an example?
Yeah, we will see it later on the Colab. But what I want to share with you is how to put it in your social science application. So for example, you have a list, you collect a list of interviews. So yesterday you saw the string, right? So a string is a set of characters between them.
Like control verbs. You control verbs. Right?
What, sorry?
Control verbs in your interviews.
Okay, yeah, exactly.
Some way.
Exactly. So you can have a string that is just one word, or you can have a multiple, like a paragraph. So this is your string, basically, because a string is a set of characters, right? So you can represent the interview transcription, so what you are collecting with transcription, or what people put inside a form, for example. You can collect it inside the list. So basically, instead of having apple, banana, cherry, you have, for example, the garden is beautiful, or I don't know, this apple is fantastic, kind of. Okay, but we will see in the Colab. Then we have the dictionary. I think already you have done it yesterday. Yeah, okay, cool. So just a brief recap. So you use it to store values in key value. So you use this bracket to represent a dictionary, to open and close the dictionary. And you have the key on the left on this double point, and then the value. So this is the structure of a dictionary. Okay. What are the properties of this dictionary? That is ordered, that you can change, but you cannot use the same key multiple times. So if you use the same key multiple times, the dictionary saves only your last value that you put in that key. So be aware of this. Okay? Good. Okay, so now I think it's time for the hands-on control flow and data structure. So before going into this, I want to be sure that you can access to this shared folder that Sumei should send you yesterday, I don't know. And you should see in day 2, the day 2 notebook.
Is it day 1 or day 2?
Day 2, yeah. You should see something like this if you open it. Are we aligned? Good. So just some tips that I want to give you to use Google Colab correctly. So what is Google Colab? Google Colab is an environment that is based on cloud resources. So when you launch something, you are connecting basically to a Google machine in the cloud. And also, these machines has on-demand GPU. That means that you can ask for a GPU. A GPU is a hardware accelerator that you can use to train like models that are very big because they need lots of power. So Google Colab also supports code cells, text cells in Markdown format. I don't know if you already saw it yesterday, the Markdown format. Maybe we can have a check it on it. And it's an output viewer. So before we start coding, I want you to save a copy on your Google Drive file, save a copy, because otherwise you cannot save your session. If you see here, you have changes will be not saved because it's not my column. So you need to go to File and then save a copy in Drive. This create a copy on your Google Drive, and then you can edit, you can do whatever you want.
How do we do that?
So I just File. So you have to open the day 2 notebook. You go to File and then save a copy in Drive. Yeah. So Google Colab also gives you the possibility to work in group, but you can save changes only one person at a time. So if you make changes simultaneously, you don't have the same changes. So before, one should work and close the Google Colab, and then the other one can open the Google Colab and make changes. So be aware of this because sometimes I have students that, I cannot find anymore my code, so that's why. If you work with shared Google Colab, you need to be aware of this. Also, like a resource constraint, be sure to select CPU and not GPU for this session at least. So to do that, you have to go to the arrow on the left. I will do it with you. So I just try to zoom in, okay? So if you go here to the arrow, you change the runtime type and make sure that you have GPU enabled. So maybe in the later sessions, you will need GPU just to accelerate. Sorry?
T4 GPU, right? The second option.
No, you don't need the GPU now, because GPU is just for like accelerating LLMs locally if you need it. But right now we need just GPU. Why I do this for you? Because if you select GPU, you have like a 1 hour amount of time before they disconnect and they delete your data. So GPU has a long job queue, so you can work as you like. While GPU, you need to pay if you want more time. Otherwise, it disconnects to you. What is? TPU is a GPU from Google. It's like a proprietary GPU.
So which is stronger?
What?
Which is stronger?
I mean, H100 is very strong, but you need to pay. I mean, these are very small GPUs that you can run for free. It's not.
So between the T4 and the Z5 E1 GPU?
I mean, this is just, if you use like specific libraries, you can have like an acceleration, but we don't see it. So I think GPU is fine because you have NVIDIA, so you can use any kind of libraries that NVIDIA supports. Okay. Let me see if I missed something. Okay, that's another point. So Google Colab environments reset after a period of inactivity. So if you connect to the cloud, after a while, I don't know, because Google doesn't give this data, the connection is closed with your machine. So what happens is that if you run cells, you are basically storing variables inside your machine, inside the cloud machine. That means that if the machine is closed, you cannot access anymore, and you need to rerun all the cells if you want, again, this kind of data. So yesterday you saw with Franco that orders matters in the cells. That means that you are saving variables inside this environment. But if you see disconnect, it is erased. So be aware of this, okay? And also remember that each session that you have is temporary. So everything that you create, because basically you have a file explorer, so you have a document partition that you can store like temporal data, like for example, Excel files, spreadsheet, images, whatever you want to work with your machine. But then this disk is deleted. So if you generate something, be aware that you have to download it. But I will stress it again with an example. Okay. Good. So are we all set? Good. Okay, so just I want to do a brief guide tour in the Google Colab. So here you have like an outlines of the notebook. So you have, for example, you have titles, you have subtitles. You can do a lot of stuff. I will show you how to do it. But basically, you can navigate easily the notebook. And for example, today we will start with the recap of previous session and then control flow and data. And then after we iterate on this day, we will move to the next section. So, okay, good. So we can explore the day 2. Just to be sure that you know what is Markdown. Markdown is basically a cell of text, okay? Yesterday you saw with Franco that you can have code or text cell. If you add like a text, you can write whatever you want. But if you want, for example, make a title, you need an hashtag title. And this is like the preview of what you are going to have. And if you add like a hashtag, that means that the title has lower priority. So if you see the title is going to be small, yeah. So if I like put this, you have a small title. It is also useful that you can use built-in functions like bold, italic. You can add images, you can add link. So this is very useful when you want to like share the project and you want to like explain stuff to your colleague, to the professor for the project, and you want to add like how to use it, how to like the analysis of the data. So it's really powerful because you have all in one. So you have code and you have cells well ordered. So you decide the order. Okay. Then, yeah, you can delete the cell. I will delete it just because I don't need it. Okay. So we already talked about cells. So what is a cell and how you run it? Yesterday you saw with Franco that orders matter. So be aware of this. And so ideally, you should not do like spaghetti code. That means that you go from a point to another, but you should like follow a straight line, like moving from top to bottom. So your program should follow like a logic vertical way, okay? So don't do like, okay, run this cell and then run the 2 cell above. So follow a straight line, a logic line, okay? Okay, so we can run the first cell, for example. So what happened here? Okay, so you will have like, this notebook is not from you. So are you sure you want to run? Because you can run like malicious code, but I mean, I do it, so trust it. So you can run it anyway, okay? So what happened when you click on it for the first time? It tries to connect. So connecting means that it creates a connection with a cloud machine, and this machine has a RAM and a disk. So it is not necessary to you to know these details, but I just tell you what you are gonna expect. This could take a while, depending on how busy are with the machines. So as we saw yesterday, we have the variable and then like a string. So we have on the left the variable equal to something. Okay. Then if we want to print something, we can we use print brackets and then we put between how can I say quotation marks. Thank you. The text that we want to print. Then if we move to the next cell, we have like an operation, a sum operation. So we define the first variable that is an integer, then epsilon, and then we sum it. So we have the new variable that is equal to the sum of the two. And then we print the element. Okay?
You look at the brackets, print, hello from the, so the bracketing is different. Does it matter?
Here?
Yes.
Now here is because you saw it yesterday, or I don't remember. Okay. So here, basically, you want to embed inside your print a variable that is out from the string. So you don't want to hardcode the string. So you don't want to hardcode Python, but you want in some way to like dynamically change this output. So if I change, like for example, the name Python, so we can have a try. So now you see that hello from Python, right? So now I can write hello from Francesco. So if I do this, it's dynamically changing. So based on the variable that I input, it changes the output, right? Okay, F is just be aware that there is a variable inside. So if you want to print a variable, you need to put an F and then use this kind of syntax. It's Python syntax.
And it is a list because
This one?
we changed here.
No. This is just a syntax on how print wants you to write this kind of variables. No, it's not related to. But I mean, I understand the confusion, so it's fine. But I mean, with practice, you will understand it. Okay, so for example, if I put again if I copy and paste again, I will see 2 times Francesco, because this keep the variable that is inside here, and it copies it and it writes the output. Okay? Okay, now we can move to day 2, so I expand it. I don't know if it is expanded or not in your Colab, but never mind. So I try to put a lot of text, because you can do it offline. So if you want to repeat, if you want to test it offline, I hope that you can do it alone with sufficient knowledge and sufficient text to replicate by yourself. Okay, so let's start with the control flow if-else statement. So if something happened, do this. Otherwise, do this. So we can take an example. Okay, can you see it, or should I? Okay. So for example, let's say we declare 2 variables. So the money that I have in the pocket and the money that I need to buy a souvenir. So what happened is that I have 4 euro in the pocket, and 5 euro is the cost of the element. So what we want to do is to see if we can buy it or not. So what we declare is a variable that how can I say? Confront. Okay, so a variable that see if the money in the pocket is greater than the money of the souvenir. So what do you expect from this kind of relation? False, right? Cool. So what does it mean here? That if is false, this is not done. This is not executed. So if it is false, we do this because it's otherwise. If this is not if this is not a condition that we met, we do this kind of condition. So we cannot buy it. Okay, so we can try to run the cell. And he said we cannot buy it. Let's, for example, try to change. We have 6 euro. We can buy it because the condition is changing, right? So this is executed only if this is true. Otherwise, if it is false, we rely on this kind of. How to indent? Indent, you can, so for example, I write my code. You see here that I have already errors. That means that because if expects something, but right now we are saying to the program, okay, print anyway, even if the condition is false. So to indent something, you need to press the tab button on your keyboard. That is the one I can show you. Tab button on Mac. Let me see. Okay. You should see this. It's like I have tab, or can you see it? It should like indent your element. Okay. Got it?
Just like bulletin.
Sorry?
Just like bulletin, like we bullet some kind of list,
Yeah, okay.
and we do intents to relate.
Okay, okay, perfect. Okay, good. I mean, yeah.
Is the exclamation mark important there? We can buy exclamation.
This one? No, it's just text style.
If we do not put it, will we get the same result?
Yeah, exactly. You can try by yourself. I mean, you can do whatever you want. Everything that is between these two is read as string, so it's output as a text. Okay.
I'm realizing that whatever you change, you're having an immediate output. Are you having running automatically to change?
Sorry.
I'm realizing that whatever you change in the code, you're immediately having it reflected in the output. Is
Yeah.
it like an automatic run or something?
No, I've just run into the cell again, because if you run the cell, it executes all the stuff that is done inside the cell. So, for example, we can buy. If I run again the cell, we have immediately the result. So it's dynamic, but because I just click on rerun the cell. Okay. So I don't have like an history of what is the output, but I have only the last output of my cell. Okay. So if I make changes, I will save only the last output of the cell.
Well, you kind of it's so quick. That's why we thought that it's automatic. Like we don't see your movements.
Okay, sorry. Okay, got it. No, maybe because the mouse is very. Okay. So I just click it on it. Okay. Good. We can go ahead. Nice. So we have a lot of comparison that we saw. So we can have a greater than equal. This kind of symbol means that it's different from something. So if you have like, I don't know, a string of, sorry?
Means not equal.
Not equal, exactly. Perfect. Thank you. So I want to try yourself to, given a number, print if it is greater than 10 or not. So you can try by yourself. I leave it a solution. Maybe you have it inside you have expanded, but I mean, you can check it if you want it. I give you just, 2 minutes, because the program is, we have a lot of stuff to do. So you can try it and then we can move on. Sumay, sorry, is it at 10:30, right? Yeah, okay, cool. If you have questions, I can go directly to you. Otherwise, there is my colleague also around. I don't expect that you know how to do it, perfectly, but I want you to show that you can do this and then you can learn this by give you like a guidelines on how to do it, right? Because it's difficult to learn Python in just one day. So don't worry. Okay, so I think no one's. We can move on. Good. Okay, so now move to a for loop. So this is what I said before. So it allows you to repeat something for a fixed step. Yes?
Hai fatto vedere come si fa l'IFES?
Sì? Sì, sì, sì.
Cioè dico la soluzione dell'esercizietto.
Ah, no, quello. Okay. So my colleague just correctly say, okay, we can see the solution of the exercise. So basically, given a number, we print if it is greater than 10 or not. So for example, I say, okay, my number is 12. And then if my number is greater than 10, I execute this. Otherwise, it is lower than 10, okay? So if I execute it, it says it is higher than 10. If I change my number, 8, and I run again the cell, it says it's lower than 10, okay? Good? Nice. Okay, we can move to the for loop. So it allows to repeat the same action many times. There are different ways to do that. So before we saw this, that means that we input a range. So before we saw 3 numbers, right? So I just change it just to make it. Okay, so that means that this iteration is done 5 times. We start from index 0 until 5, excluded, and a step of 1. So basically, this for loop is doing 5 times. What does it mean? That means that everything that I put here, that is indent here, it means that it is executed 5 times. So everything that I put inside here is executed 5 times. Okay, so just we can go directly to an example. Okay, maybe it's better to also see this. So the for loop can be numbers. So we set a range, so from 0 to 5, 5 excluded. Or we can loop in a list. That means that if we have a list, the one before, apple, banana, cherry, we can loop inside this list and, for example, print them, change them. I don't know, you can put whatever you want. The important thing is that it is inside it is indent inside the for loop. By the way, I also give you references that I found these Butri schools very good to learn Python. So if you want to check it later, it's a good, I personally use it, so it's a good way to learn. So for example, let's take this list. So we have responses that are equal to a set of lists. So we have yes, no, yes, yes, no. So it's there are responses, right? So what we want to do is to loop inside this list. So we move from index 0, 1, 2, 3, 4, 5, and we want to print the element. So what we do is for each element in our responses, we print the element. So what happened is that the 4 start from index 0, and then the first iteration is the element is yes. So we have this type of association. The next iteration is element 2, element index 1, element 2, 3, and 4. Okay? So if we execute it, we will see that it prints all the elements of my list in order. So we start from the first one, second one, third one, fourth one, and so on. Okay? Then we can combine for loop if else. This is more, I would like to see you that you can do it. that means that we can, for example, we want to count how many times we have yes inside this list. So what we do is we take the same list of before, we initialize a variable that is 0, that is our counter, and then we loop inside the responses, and if the element that we are looking at that moment is yes, we increment the variable. So we take the variable count yes, and we add 1. So that means that we encounter in some way the yes. And then we print finally the number. So what happens is we loop inside our list. If that element that we are currently looking is equal to yes, we count the element. And we update the variable with +1. And so you see that yes is found 3 times. Okay?
What's R here?
Sorry?
R, what's R?
This?
Yeah.
So R is basically, you can, it's a way to declare the single element that you are looking at that moment. So it's a variable that looks, that has inside the element that you are looping in. So if you start from the beginning, for example, R would be yes. Then the second iteration would be no, and so on.
Is it fixed or it's up to us to
use this? Yeah, it's up to you. I mean, now it's R, before it was like element, so you can change it as you want. The important thing is that it has not to be the same of responses or count yes, because otherwise you override the value and you have something messy, okay?
So we can write X, Y, Z, anything in the part of R, right?
Yeah, exactly. So, exactly, it's just an alias to say, okay, this is the element that you are currently looking, but inside this loop is valid. So R would be the first time yes, no, yes, yes, no. Okay? So if we change it, for example, and we run it again, I expect the same output. Okay? Good. So a brief recap of lists. So yesterday you saw with Franco the list. So this is an example that I reported to you in the slide. So we can run it and see why it does not go away. Okay. So we have my list, print, and we print our list. The question that you said me before, the underscore, you can put whatever you want. The important thing is that you use the same value, the same variable name in your program. Because if you see here, you have my list that is not matching with the current one. So if I run it, I have an error. Okay, I don't have an error because I have, because my list is already in my machine. So to make it, to make an error, I put no, okay. So because, okay, my mistake, sorry. Because I run it too much time, and then the machine know that my list and my list with underscore is the same. So, okay, my bad, sorry. Okay, never mind, I mean, it's fine. So this is the example of survey responses that I said to you before. So the interview responses. For example, you have a set of small responses from a user. Do you have a question?
I just wanted to ask a quick question. If for any reason we have to change the name of the variable, but we have used it so many times that it will become very hard to change it. Is there a shortcut method to change all? Like,
yeah.
If all are the same name, can we just select all and change all?
Okay, let me check if I can do it. Okay, no. So here on the left, you see that you can find a replace. So here you can search for, I don't know, my list, and replace it with my list. Be aware that if you use it in another context, in the same collab, you will change for everyone. Okay? Let me see why it doesn't find. Maybe.
Because you made it like
Oh,
it's separate.
cool. Great. No. Okay, got it. Nice. Okay, so we can replace all or we can replace just one. But yeah, maybe it's better if you check every time that you are changing the right value. So we can replace all.
But it is possible.
Yeah, exactly. So if you want to look something, yeah, there is this find and replace function. Okay, so we can do the same with like a list of string that are small text. And to print the first response, this is the syntax. So we take the list variable name, and then between square brackets, we indicate what kind of position we want to print. So as we said before, the position starts from 0, because in computer science, we start from 0. So we have index 0, index 1, 2, and 3. So if I print this, what I expect? What do you expect from this? The first one, right? Cool. Then with len, that means length, we can have the length of our survey responses. So how many elements are in our list? So in this case, we have 1, 2, 3, 4 elements. So this is basically what I have done, but in a programmatical way. So len something, usually you have the length of the elements inside your variable. Then if you want to print, for example, the last response, but you don't know where it is the last response, you can use -1. -1 means that it takes the last element of our list and it prints. So it takes garden is very nice. If we can run the script. So you see that public transportation is unreliable, what we said before, 4, and the last one. If I want, for example, to print the 0, 1, the third one, I need to start from 0, so 0, 1, 2. So I change it to 2, I rerun it. It's not anymore the first, so I have to change, maybe it's better to change the print also. And you see that you have now parks need maintenance, okay? This is how you access to lists, okay? And how can you add element to the list? To add the element to the list, you need to use this dot append. So you use your list, dot append something. So between these brackets, you put what you want. So you put a new string that you want to append. What happened to this string? It is append at the end of the list. So it would be the last element that you insert. Okay? So if we run it, we have before the full list, okay? Before adding a new item, we can see the len. And then we can see the len after adding the new item. What do you expect? A +1, right? Because we have added a new element, just one. So what happened is that we have the full list that before it was 4, and now it's 5, because we have added a new element with dot append, and it has been append at the end of the list. So if you see here, this is truncated, but then we have added again, okay? Okay, so a common beginner mistake is that you want to access to an index that it doesn't exist. So for example, 10, you cannot access to an element that is in the 10th position because it doesn't exist. So what happened is that you will have an error, okay? List index out of range means that the index, so the list index is not present, okay? So just to give you that errors are common, so expect that. Yeah, explain error, I think it's, okay, Gemini. Okay, cool. Okay, so I would like to try yourself to add a new response to the list that we are currently have work on, so survey response, and print the first and the last item of this list. I give you 2 minutes, then there is also the solution. So let me see. Yeah. Sorry, can I ask you water? Thank you so much. How is it so far? Okay. What is going on? Good? We can see the solution? One moment. I have my badge. Okay, so we can move on. Nope. One moment. 30 seconds. Okay. Yeah. Okay, so the solution is we take the same list of before, then we use .append function to append a new response. For example, this is a new response, but you can put whatever text you want. And then we print the first element by access to the first index, so index 0, and then the last response that is -1. The last response, since the operations are done sequentially, so it's done from the top to bottom, that means that we have appended a new element at the end of our list. So what we expect here is that in output we have this is a new response. Okay? Okay. Good. Now we can move to dictionaries. So dictionaries are key value pairs, and it helps us to structure data in a key value manner. So, for example, we can declare a dict like the key is the brand, and then we have the value of the key. We have the model and the value, the key and the value. So to print the dictionary, you simply print it in this way. So, I mean, in Python, there are lots of ways to print stuff. So, for example, before we we saw with F, but this is also a common way to do that. So you basically append stuff so that you want to print. For example, here is a string that you want to print, comma, and then the variable. You see that they have different colors. So that means that this is text and this is a variable. If you want to print, for example, since this is structured, that means that it has an order, it has a structure that you can, in a predictable way, interrogate, you can query the structure. That means that you can ask, for example, the key brand. That means that you want to access the value that is inside brand. And what I expect from this call, from this variable, this function here, is Ford. So to access a key, you use your variable, dictionary, and then between square brackets, the key that you want to access. The key could be also a number, and the value can be any object, as we saw in the list. So for example, it can be a string, it can be a list, it can be a dictionary, it can be, I don't know, a number, so it can be whatever you want. How to print all the keys that we have in our dictionary? We use this magic function, .keys, open, close. And if we want to print only the values, so before we print only this, then with the values, open, close, we print only this, okay? This is a way to inspect your data.
I'm sorry, Francesco. How are the keys different than values?
So the key defines maybe it's better if I saw this example. So this is exactly the same dictionary structure that we saw before, but with a different keys and value. So what I wanted to show you here is we have the key interviewer 01 that has this age. And then we have key interviewer 02 that has this age. That means that we organize our, so the key represents the value that is the most important one that you want to save and to retrieve. And then this key is associated with something. So when you want to save something and you know that there is this association between a value and another one, you use usually use the string to represent what the key means, what the values means inside, and then you add the value. I don't know if
Yeah. So okay. So for the keys, if I say this dot keys, I would get interviewer 01, interviewer 02, interviewer 03, and for the values, I would get 23, 45, and 30.
Exactly. Yes. And if I, for example, use this structure here, interviewer 02, I just get the value of that particular key. So in this case, it would be 45. Okay? So if we run the cell, we see full dictionary. It's like plain text that represent my dictionary. The brand key content is Ford. All the keys of the dictionary, we see it, values. If we run the same example with another dictionary, you see that we have created the dictionary inside our memory, and then we retrieve it, for example, interviewer 02. Or we can retrieve, for example, 01. Okay, so depending on what you put inside this, it changes your output. Okay? How can I add a key to a dictionary that is already initialized? So for example, we have this dictionary that we have declared. Okay, this is my new dictionary, perfect. Now, a new interviewer comes. I want to add a new value to this dictionary. So what we do is variable, so my dictionary, into the brackets we put the new key, and then we say, okay, into this key you put this value, okay? And then we print the updated dictionary. So what I expect is that, maybe I can show you. So this is before adding. Okay, after. So this should be a bit clear. So what happened is that before adding the element, we have our key and value pairs. And after adding the element, we have a new element that has been appended to the end. Okay? Yes?
So in this case, you don't need to use append functions, right?
No, exactly. So it's different from list. You specify a key, and then it automatically do it for you.
So it was like for everything, like for every cases.
Yeah.
We don't need to use append.
No. It's not a function inside the dictionary structure.
It's also possible to just write respondative. We don't need to print the list of respondative. Simply we can add.
Yeah, exactly. It's just for you to see that you see that it is applied inside the new one. Also, for example, if you want to like change the age of I don't know, interviewer 02, what you do is, for example, I create a new cell code. You just select. Okay. So in computer science, we usually copy paste something because we are lazy. So feel free to copy and paste code because it's much faster and yeah, it is time saving. So for example, I take this function. This function means that given this key, we want this value. We can use also this function not only to add elements, but we can also like change the value of a specific key. So for example, if I want to change the value of interviewer 03, I just do this. So I want to access key 03, and I want to change the value to, I don't know, 1. And then we print again the dictionary. Dict. Okay. So if I print it, you see now that interviewer 03 has a new value that I have done, that I have put it inside now. Okay? This like override your value before. So be aware of this. So when you execute it, the program takes your last input and your last command. And you cannot revert it if you like. Okay, in this case, we can revert it because we have printed. We know that the program is simple. We know what type of value is inside. But be aware that you need to know what your code is doing. Okay. Okay. So a common beginner mistake is key error. That means that the key doesn't exist. So for example, I want to retrieve interviewer 99 that is not available in my dictionary. So what happens if I execute it? I have a key error. Interviewer 99 does not exist because our dictionary does not have the key interviewer 99, but only from 1 to 4. Okay? So instead, to prevent this, maybe it's better if I explain to you this. So to prevent this, a safe way to get a value and to return something if it is not found is to use this function .get. So the first element is, okay, I want this key. If this key is not found, so if I cannot find the key, I return something. So the default one, the default behavior, okay? So if I run it, I don't have anymore the error that was before, key error, but I have not found. That is the value, that is the default one if the key is missing, okay? For example, I can write, I don't know, hello as a default value, and I have the default one. This is important because when you have errors, usually in a program, the program stops. So if you have like programs that are executing automatically and you have an error, you need to be aware that errors can stop your work, and then you need to rerun stuff or you need to, so be aware that errors should be like in some way detected and then fixed in some way, okay? This is just a general idea. I want just to give you a general idea. Be aware that keys are uppercase sensitive. That means that you need the exact value of that key. So if you use, for example, the E that is lowercase, it doesn't retrieve anything because it's it's case sensitive. That means that upper and lower is important. For example, if I change it to E but uppercase that exists, I don't have anymore the error. So be aware of this. Okay? So I think we have finished. You can try yourself. So I give you like an exercise, but we can. I think we can stop here and have a break. Okay, so I think we can restart. Okay, so the first session was just a recap and some additional core concepts of Python. Now we want to deep dive into how to manage these datasets, this data. So the today's focus is how data even gets into a form that the machine can analyze. We have already seen some data structure. There is like lists or dictionaries where we can, in some sort, organize data for the machine and then use them for our task, for our goal. And the second question is how to process this data to get insights. So if, for example, I have a data set, I want to see what kind of data are inside, what kind of, I don't know, data type, or statistics. We will see it later on. Okay, so we start with the dataset and pandas library. So why we need to pre-process the text? Because the main challenges are that there are inconsistent formats. That means that we don't have structured data. So for example, we have, I don't know, some numbers that are string, some numbers that are not. Or for example, we have a file that is in Excel, but we want it in another format. So we need a way to consistently have this format because it helps us a lot during building our workflow. Then we want also to filter out noisy data, unnecessary data. For example, we have a data set with a set of like news, and we are only interested into the title, the date, and the summary or the news. But we don't want the links, we don't want any kind of like extra data. So this helps us to like clean the data, to remove it, and this saves space, and it is much efficient and organized. So how is text represented in a way that machine can work with? What is a dataset? A dataset is a structured collection of data organized in a way that you can use it for analyzing and processing the data. So it's a way that you know that you have the format, a predefined format of your data, and then you know how to access it. You know how each line, each element, each item of your dataset is structured. So this is really important because of when you do automatically, you need to rely on something that you know how it works. Data is typically arranged into rows and columns. For example, if you think about Excel, Excel is a perfect example of a dataset. It's a spreadsheet, but more generally a dataset. That means that we have rows that represents our data, and then columns that represent the meaning of that particular data. Okay, is it familiar for you, this kind of metaphor? Okay. The dataset can contain any kind of data. So for example, if you think of Excel, you can have text in one column, a number in one column, and so on. So you can have different type of data. And why the dataset is so important? Because it's the fuel of machine learning models. So if you have, for example, you want to train a model that classify cat and dog, you would have a dataset with lots of images of cat and lots of images of dog. And you have also the label that is belonging to that image. So for example, you have the image. So you have your dataset that has the row image and then the label. Image and label, image and the label. And every row has its own data. This is very useful because you know how to access to the rows. So it's really important that you have a structured collection and not a messy one. This is an example that I want to show you. So a dataset is basically a spreadsheet of Excel. So how to load, filter, and manipulate get insights with Python. So with Python, we can use pandas. Pandas is a library. As you saw yesterday with Franco, libraries are like a collection of code that someone else write for you. So you just need, you don't need to know the logic inside this kind of library, but you know that if you give in input something to the library, you have a particular output. So for example, you want, to change all the, so you have a column of numbers and you want to filter out only numbers that are greater than 10. This can be done at scale with pandas, and it's a very short function that you can call, and so it's easy to use it in your code. It's easy to use in the Python program. So the advantages of pandas is that they have a structure that are two. So the series that is just a row, a column, and then the data frame. Data frame is basically a spreadsheet. Is a spreadsheet, okay? It's a tabular data. As we said, pandas is very powerful to filtering, aggregation, joins, transformation. We will see some of basic manipulation of data because we cannot cover all. But yeah, I will give you some advice. And also pandas is very useful because you can, with just one command, read an Excel or a CSV that we see later on what this is, and you can write or you can export your cleaned dataset. For example, if you want to share it to your colleague or if you want to publish it online. Okay, So we saw before that we have the data structures of Python. That one was related to Python. So Python has its own data structure that is lists, dictionaries, and tuples, for example. Pandas, instead, has its own data structure. So it means that it has its own way to represent the data and to structure the data in a correct way. So the main one are the series, as we said, that is just a column, okay? So you have the index and you have the value. And this is the name of the column, the same that you saw with Excel, if you are familiar with. Data frame is what? Data frame is a collection of multiple columns. So it's a row by column, okay? Good. Okay, now we can see live how pandas work. So what I want to do, we can go ahead with the same notebook that we saw before. But what I want to do also from you is to download this assets folder from the shared link. I will guide you through this because we need, in this assets folder, I put some small data sets that we can use to practice on it, okay? So if you follow me, okay, so I open the shared folder. You should see something like this, right? So just right-click on the folder and press download. And this will download on your computer. Maybe you have to say, okay, accept this download. But generally, it's preparing the zipping file, and we wait for the downloading. You should do it all, because otherwise the notebook doesn't work. Okay. So now I have my assets, okay? And these are the data that I want to import inside my machine. So stay with me. You should now be already connected to the remote machine, right? You should say you should have like a V, green. That means that you are connected to the remote machine. Otherwise, reconnect or connect again if you close the tab. Okay, are we all same line? Okay. Okay, so here you see that we have files. Files, it's like an explorer. So it's basically your folder of the remote machine. So here you say, okay, here I want, we have all the files that the remote machine can look at or write at, okay? This is really important. So this part is temporary. That means that when you disconnect to the machine, or you, I don't know, you close it, I don't know, you have to restart, you lost the connection, this one is not preserved. So anything that you put here inside is deleted after a while. Okay, so be aware that this part is deleted. So now we need to import the assets folder that we have done before, that we have downloaded before. So to do that, you just simply upload to the remote machine the file. So you click on this icon, okay? And you will see, you select where the assets are in your machine. Then you select all of them, okay? And then you upload them. Okay, so I have a warning that it is the same that I said to you before. Ensure that your files are saved elsewhere. This runtime file will be deleted, okay? This is especially important when you create a new Excel, a new file, because otherwise you lost it, okay? I'm waiting for the upload. Is anyone having problems?
Let's say I have lost the files over here, but I do save on my computer.
Yeah.
When I re-upload it, can I re-continue the job or start from the beginning?
I mean, depends on how the state of the file is. If it is like partial, I mean, you need some way to like start again from the last row, for example. But usually you should like end the program and then save. It's better because otherwise it's very critical to manage the code in this way.
After uploading the file, do we need to again go to the file and save it to the drive, or just need the...
No, this is just saved on the machine. You don't need to, yeah. So are we all set? Otherwise I can... Yeah? Maybe...
No problem.
Ah, okay. Ah, sorry. Praticamente li sto facendo caricare il file, i miei CSV da una cartella locale del computer, gli faccio caricare i miei file che hanno scaricato dal drive. Perché io ho creato un drive con dei CSV dentro e loro devono caricarli.
Se aprono il notebook dal drive folder, non dovrebbero direttamente vederli lì?
Che devono fare from bla bla bla, non volevo...
Quindi cosa gli puoi far fare?
No, niente, praticamente tu vai qua, ok, assets, fai download, lo scarichi e poi vai su file e fai l'upload dei file che ti interessano.
Okay. Who's struggling?
Sorry, please.
Will you take these assets from Pandas?
They?
Yeah, these documents like
This one?
yeah, these are.
Okay.
Take these from.
Where?
Yeah.
So these are just example. So for example, okay, you're right. After this session, I will show you Kaggle, where to take data sets and so on. So basically, I just found these data sets inside that repositories. I just downloaded them. For example, this small new data set, I just created it because I wanted to shrink it just for learning purposes. Yeah, but we see where I just take it in a, I don't know, I think 45 minutes.
I just upload the zip file, not one by one, does it make it?
No, you need, okay, sorry. You don't need to upload the zip file, but you need to unzip the file. So you double click on it and you will see a new folder with all the file, should be 4. And then you upload the 4 file, not the zip one. Okay? Maybe I can...
So we have to upload them like this?
Yeah, exactly. Then download them.
They are downloaded now.
Yeah, it's waiting.
Then upload them.
Yeah, you should have... okay, now. No, wait. Open the folder. Oh, okay, you need to upload this one. So you just... Okay. What is your... No, extract all. Sorry. Extract all. Okay, go ahead. Nice, and then go back to the column. Upload. Okay, and then where is your folder drive? The last one. This one, no, this one. Yeah, open it, and then select all of them. Okay, open. Good.
Thank you.
I've done something. I don't know what I've done. So all of these things come up.
Okay, now you have uploaded all the. I think you have uploaded all your PC.
What?
Okay, let me see.
No, it was the document itself. I clicked on one of the files which were here.
Where is the drive that you?
The drive I downloaded from.
Okay.
This one. It was already. It's here. It's
Okay,
already
perfect.
downloaded.
Okay, open it. Cool. Double click on it. Okay, and then you have to extract all.
Okay.
Okay, extract. I mean, yeah, drive zip automatically, and this is okay. Then go back to the notebook.
It's here.
Okay, cool. And now you can upload it. Select assets. I think is this one. Again. Okay, select them. Okay, open.
Okay.
Okay. Okay, now you have all.
Okay.
Everyone is done, I think.
Yeah. Fine. Okay. Okay, so just a quick note, you can just see the file. So CSV's file is like a spreadsheet, but different from Excel. Usually in computer science we use CSV because it's easier, it's lighter to use, but for you it doesn't change too much because it's the same structure of Excel. But it's more efficient for the machine, okay? So if you double click, for example, on one of these for, I don't know, CSV, you see the data set. So you see the column and you see the row. So for example, this is a news data set that contains title, publication date, the link, and the description. So this is a structured data set that has its own columns and rows. Okay? The same could be done. BBC News is very big, so it can take a while. But yeah, you can do the same with other data sets. So you can have like an intuition of what it is inside, and you have a look inside. Okay. So we can continue. Okay, so pandas, we saw that is a library, okay, that has series and data frame as data structure. A data frame is the most important one because it's the one that you probably use in research and your project work. So, starting with series, the first thing to do is to import this library. So to import the library, we just use import name of the library as PD means that we give it an alias to call the library. So it's the same of writing pandas or PD. It's the same. But we prefer to use PD because it's very common that if you use, for example, a code of someone else outside, it will probably you will probably see PD because it's a standard now. So you just run the cell and you import the pandas. So a series is a column. So we can create a series from a list. A list, we saw it before, is a is a set of items ordered, and we can convert this list inside a column. So if we run this cell, we see that we have our list, 23, 45, 31, and so on, as a column. So we have converted in a column of Excel, for example, and then the name is the name of the column. So in this case, we have associated age to the name of this list, okay? So we have the column, that is basically the list that we are converted, and then we have the name of the column that is now age, okay?
Excuse me. These are numbers are just we gain this, right? Not in the data which we are uploading.
No. It's just be uploaded because it's easier than now to go with the flow. Because otherwise I need to like stop you, and then so it's for me seems to be difficult. But yeah. No. Now we just see like toy example on how to deal with series and data frame. Okay. We can also use someone speak. No. We can use also dictionary to create series. So for example, we have the respondent age of before. So we have key and value, and we want to convert it to a column. We use the same function, pd.series, the variable, and then we append again the age. So in this case, we have that each row has its own key with the column corresponding to the age. Okay?
Sorry, I'm getting the mistake, but I didn't click anything. I had the same code and everything, but I'm getting the mistake.
I think there's an error.
It says the name PD is not defined.
Because you hadn't run this cell. Because you need to sequentially run it, okay? The 34 cell. Okay. So be aware that, yeah, it's really important that you run the cells sequentially. Otherwise, the code, the Python program doesn't know what you are doing. And so they need in some way know which function correspond to, okay? Okay, now we move to a data frame. Data frame means that we have two types of values. We have the row and we have the columns. So in this case, we have a dictionary that has the keys and the values. Keys, values, keys, values. The values is a list, okay? The list means that these values would be in a column, as we saw before. So before we saw that this key and the value corresponds to the index, so the value of this kind of row, and then the column, okay? So we want to do the same, but expanding it to more columns. So we saw before that more series, so more columns create a data frame, okay? So a row is in a data frame is a composition of multiple columns, okay? So if we run this, we see that we have, maybe I can expand it, no? So we have this ID, that is the name of my column, okay? Contains this value, so this list. The same for age, the same for income, the same for gender. Okay?
So you are making an interview and you have 4 respondents and you are coding their answers manually.
Yeah, exactly.
This is the practice of.
Yeah.
Yeah, we are making a survey and we have 4 respondents with these IDs, age, income, and gender, and I'm manually coding, creating my data myself.
Yeah, exactly. Mm-hmm. So I just started with creating my own data because it should be, because if we scale to a data set, it's difficult to understand. So I just started with my own data, with small data.
Yeah, but then what's the sense of importing data from Panda then?
No, I mean,
Can I create the same exact thing?
yeah, you are right. I mean, you need data sets in like Excel or CSV for file, because if you want like huge data, if you want to like share data between colleagues, if you want to, I don't know, open it with another program, if you want to store it because you want to send it for public release or stuff like that, you need a way to store the data not inside your program, but you need a way to store it outside the program. Because with Excel, for example, you store all your data in a file, and then you can reuse it whenever you want, right? You can open it, you can, I don't know, edit it, send it to a colleague, stuff like that.
We haven't uploaded any data yet. Import pandas SPD is to machine to understand that you are going to use CSV file. So we are going to use a big data later on. But
yeah, exactly.
The practice of manual coding.
No, maybe
pandas SPD doesn't upload any data.
What I thought was like we uploaded already those 4 files.
No, this one are used.
Use them later on, but
yet.
Okay.
Show us that this is structure.
Okay, I'm sorry. I'm sorry for. Okay, maybe it was my bad. Sorry. Okay. No, I did it because I think it was easier to follow than the logic. But then, okay. So just now we are just looking at toy example just to see how it works in a small scale, and then we saw it at large scale with a CSV file, for example. Okay. So this looks like a table now, right? So it's a table that is from Excel. So data frame is a table with labels. So it means that we have rows that have indexes. So we have row 0, row 1, row 2, row 3, and so on. And then we have columns that has its own name. That is the same of Excel, right? So if we want, for example, to have a specific column. So for example, I want to investigate only this. What I do is to call this function here. So df, what is the variable that contains my data. So it's the same of before, but translated to a more advanced way, okay? So we have the variable that is equal to something. In this case, we have the variable df that is equal to the Panda data frame that we have created, okay? So I take this variable, df, that I take with me inside the code, and then I query it. I ask to him the age. So in this way, with these brackets, I can ask for a specific column, okay? So in this case, I have age. So if I print it, I have only the age. And this is a series, okay? This is only a column. The type means that what are the type of data that I have inside. In this case, floating. 64 is the precision, but floating means that you can have points. So you can have this kind of data with the point. Sorry?
Decimals.
Yeah, exactly. Yep. Yep.
Can you go to the last part? Yeah, here. We wrote twice df, right?
Yeah.
I don't understand why we wrote the last one.
Okay, good question. So in a notebook, if you write just the variable at the end of a cell, it automatically output the value. So without like using print df, we can directly print the value without using print. So it's just a way to print something. It's a shortcut, yeah. But if I do this print df is the same. Maybe a different format, because this is a format of Python on how it writes code, but it is the same, right? This is a more like interactive way to have the data set. Because like Colab probably interpret this as a interactive data frame. Okay. Okay, we can move on. So we saw how we can select a data frame from the column. Okay. For example, if I want to select instead the ID or gender, for example, gender, we can change it directly, and we have the column gender. This is a way to like filter out just what we want and what type of data that we want. We can also, like, I don't know, we want just rows, so we want just values of rows that has a particular number or a particular condition. In this case, I want only people that has the age greater than 30. So with this syntax, what I'm saying to the program. So take the data frame, then instead of just taking the age, take the column of the data frame where the values are greater than 30. So basically what I'm doing is a filtering, okay? So we are filter out rows that are not, that doesn't have a values lower or equal to 30. So we have only values that has the age that is greater than 30. So if we run the table, we see that, maybe I can give you a comparison. So here I reselect the column age, and you see that the age in this case is 23, 29, or not defined. So in this case, I have filtered out all the age values that are greater than 30. And in this case, I have only one, because only one has this condition that is true. Okay? Is it clear? Good. For example, if I want to, I don't know, include also 29, I should say, okay, take all the rows that has the age greater than 28. So I have also now the 29 age, okay? I can also like filter for income. So if you want to filter for income, you just change the column name. So if you want to filter income, I don't know income what was, we can just check it very quickly what is the value of income. And we can set like a threshold of 1,700. And what I expect is this value, and this value should appear, okay? And so I have filtered out this. I can do the same with the minus. So it's the opposite, right? And also with equal. So the same logic operation that you can do with like if else or loop. So it's a mix of logic operation that you can use also in other kind of situation. Okay? So for example, if I do income equal to 1,700, I will see no table because there is no income option. And if I put, for example, 1,800, I have just one because it matches. Okay? Good. Aggregation. So you have your collection of ages, and you want like to create statistics on it. So for example, you want the mean of the ages of this kind of data set. So for example, the scenario is you have collected a lot of interview information. You have the name, you have the column of the name, you have the column of the age, you have the column of, I don't know, the description of the guy, the gender, and the response, okay? I'm interested in know, okay, so how is my interviewer mean age? So I want to know this kind of information, okay? So what I do is, okay, take just the column age and then mean the values only of this column. So with the mean, dot mean, we can have the average age of my entire dataset. So if you think you have, I don't know, 10,000 interviewers because you have run a large-scale experiment, and you want to know the mean value of your candidates, you can do it simply by just running one command, okay? So the syntax is, we take again the data frame, we input the column that we want, and then we dot mean means that we use this function to get the mean value, okay? Okay, there is a bunch of stuff that we don't know, but the important thing is this. So the average age is this one. This is a way like to, it's another data structure that we don't see, but it's a way to like store numbers for efficiency. But the most important part is that you understand that 29 is the value that you are interested in. I can do the same with max. For example, I want to know the max candidate, age candidate of my dataset. I can run it and let's say 35. Is it correct? Let me see. Okay, so I inspect the age again. Yeah, okay. And then we can do the same with mean. Okay, so the most common thing to do with a dataset when you have it is to see what type of information you have inside. So, first of all, I'm not talking about this, okay? So this is not discussed now. We are right now just discussing a dataset that we are building, just for teaching purposes, okay? So I'm building a dataset with a dictionary. So what I do is, okay, I have a column respondent ID with these values. These are the column values. Then I have the age of each element of each responder. And then I have a special column with the main issue that, for example, the interviewer report. For example, the transport, the housing, park, and transport again. So in this case, I build the data frame from a dictionary. So what happened is that I have my pretty data frame. So I have my data that are structured. That means that I know exactly where they are, and they are well organized, okay, in rows.
Francesco, what would happen if you didn't write the last part with survey/df?
Survey.
What is that for?
You mean
You're not pulling anything from, you're not importing data.
Yeah?
Why is that part necessary, the last part?
You mean this?
Yeah.
Because otherwise, if you...
And the other one.
Why do we have a new name of survey?
After the hashtag, build the data frame.
Sorry.
Why do we need that part?
Can you explain it again?
Okay, so you have the second hashtag says build a data frame from the dictionary of the lists.
Yeah.
So I don't understand the second part. Why is that necessary?
Why? Because in this case, you have a structure that is a dictionary. So you can access to it only with dictionary function, okay? But Pandas is way efficient and way structured. So you can structure better your data, you can organize better your data, and also it is very important because with Pandas you can like export data like in Excel format or in other stuff that you cannot do with just dictionary. Because if you want to use just dictionary, it's difficult to like manipulate it, to clean it, it's very it's very difficult to use this kind of tools. So it's better to, if you are working with rows and columns, so your data are suitable for rows and columns version, it is better to convert it to a data frame, okay? Yes?
Thinking, can it help us to organize random data? For example, if our data is not structured, can we use, for example, any function to organize our random data?
Yeah, I mean, this is like an advanced way because, I mean, you need first to like understand how messy data are saved. And then you have lots of steps to clean it. But we don't discuss it here because it's like very hard. So it will be too much. I will just give you like the basic stuff to implement it and to start to understand how pandas work. And then, yeah, there should be also that part. But I mean, that part is a bit advanced, so I don't cover it. But yeah, I mean, you should, if I think for a workflow of this kind of task, I would say you need to understand how messy data are, because, okay, they are messy, but I mean, there should be like a logic, otherwise it's a completely discarded dataset. And then you should like convert this kind of messy files inside in a structure that you know, for example, the data frame. So you want to move from a structure that you don't know exactly, that is very messy, that you are not familiar with a structure that is a data frame. So we don't see that part, but we see how to deal with pandas, yeah. So I hope that I reply to your question. Yep.
As I understand, data frame is a shape of table, right?
Is that?
Is a shape.
Yeah. Yeah, exactly. So it's basically a table. You have row and columns. So it's a 2D dimension.
This code makes it a table.
This code, yeah, makes it, so it transforms, it converts a dictionary that is columns with the key and values in row, okay? So one thing that I want to show you is that you see that for each candidate, R01, R02, we have a corresponding value, okay, in the row. That means that if we have 4 candidates, we need 4 of them, right? So we need to full the data frame, the data set. So if we miss, for example, one value here, for example, we have all the responses, we have ID, we have the age, but we don't have, for example, the last response of this guy, so the R04. So for example, we remove it, okay? So I just delete it. What happened? We have a mismatch because we have all the responses, we have all the age, we have partial information of the main issue. That means that we miss this transport. So what happened is that we have an error. Let's say, oh, all arrays must be the same length. That means that you don't satisfy that all these values, all this row has its own value, okay? So if I put it back, the error disappears because I have completed my data set. Yeah?
What if there is no data for that section? What if it doesn't come from the survey?
Okay. Sorry?
No, we often have missing data.
Oh yeah, you often have. Okay. Yeah, I mean.
Missing is none. NaN for Python.
Yeah, exactly.
Not in stata and SPSS. But you have to put it.
Yeah, exactly. For example, if you don't have, you put, for example, known, that means you don't have the data, it's fine. Okay? Yeah, good observation, thank you. So you always have to preserve, in some way, the dimension of your dictionary, of your dataset. Okay, go back and then okay, so we have the full dataset. So now we want to run a bit of statistics just to see how our dataset is looking, just to have a very immediately quick view on how the dataset is made of. So we can use, okay. So we can use the same dataset that we created before to get these insights. So to get these insights, we can use, for example, .head means that you ask to the data frame to output only the first 5 rows. So you just have a look on how data are. You don't need, like if you have 4,000 rows, you don't need all of them, because otherwise you have like an output that is so big that you cannot scroll it. So just to see, okay, I want to just to look inside how the dataset is, you just use head, and then you just print the first 5 rows, okay? Shape, what is the shape? Is the number of rows and columns that you have of your dataset. In this case, I expect that we have 3 columns and 4 rows, okay? And then the columns. Columns, in this case, print the name of each column, okay? So we can run it together. And you see that we have row first, column, second number. Row, column. And this is exactly the shape of our dataset. And then we have the column, just to, I don't know, you want to inspect which kind of columns you have inside your dataset. You can just call this function here, dataframe.columns, and you just see the values of the column. We can use also .describe, that is another built-in function done by someone else that gives you statistics, and also another function that is info. So we see together what does they do. We can run the cell, and this gives us just a quick description of the dataset. So in this case, I can just okay, why it is missing? Let me see. Okay. Yeah. So .describe usually gives us just some statistics about our number data. So in this case, we have just age, that is a column of number, because we cannot compute like a description of like the count, the mean, the standard deviation and stuff like that on a string, but just on columns that contain numbers. So in this case, I have the statistics of my column, now age, and we can see directly, for example, the mean, the max, and all the kind of statistics that we usually want to see. And then we have the info, where the info gives us the type of column. For example, if the column is null or not, how many elements are known inside the column, and what kind of type is the column. So for example, in this case, we have age, that is an integer, that means it's a number without the decimal, and respondent ID is an object. In this case, I don't know why it outputs only object, but it's a string, okay? Probably because it's they differentiate only with the number. Okay. I would like to, if you can try yourself to, so given the code below, print the head of the dataset, the statistics, and only the column exam score. So I have already prepared for you this dictionary, and I want you to extract the head of this data frame that I have already converted for you. So this is the data frame that you have to work on. Then the statistics and the column exam score. Okay, so we can give you 3 minutes to try. If you need help, raise your hand. Okay, can we move on? Yeah. Yep.
To be honest, I just to exercise the possible solution.
Yeah,
But
that's
why
nice.
these
Because
things is
yeah,
red?
you see that what does it? We can read also the error. Unterminated string literal means that you have a problem here. You see that it indicates where it is the problem, and it is like a suggestion. Also, you see that you miss something. You have to close something.
I need a
You
space.
see the red one? Yeah.
So I'm deleting that.
No, because print you need to like say what to print inside. So the problem is that you are not closing the bracket. Because if you see, you close the bracket just for data frame.
Is it?
Yeah.
Come on.
Try now. Yeah.
Come on. Thank you.
No worries. I mean, like errors like that, usually they are like they give you a hint. Like
I see. Thank you.
Yeah. You are a skill guy.
Why?
Because you're using iPad.
Yeah, well, it's okay. So the thing is, I was thinking about. Yeah, so I'm using this pd.fm.data print, and I'm getting the data of above one, like transport housing.
Yeah, that's nice. No. Yeah, okay. Because you have in memory all the data that we have like run the cell, right? But which variable contains this data?
Which contains this data?
So data is your current what you're looking for, right? But you see that the variable df is equal to this data. So you are using the wrong variable.
Okay, so this is equal to this data.
No, you see that you are using survey df. That is the
Above one. So this one is which one?
This one is the new one, df. So you just need to, instead of using survey df, just df.
Okay,
yeah. No worries. You can try it. Yeah, don't use the spaces between the dot. It's not necessary.
My laptop broke yesterday.
I'm coming. Where's?
My laptop broke yesterday.
Okay. No worries.
The first two have no problem, but on the last one I couldn't.
Okay, because you have the wrong brackets.
In here, right?
Yeah, exactly.
It's the
square.
Yeah. Okay.
But that's the only case you use though. So you know, after some time that you see that it's gonna be fine. And so for example here.
Okay.
I noticed a small difference in the command we wrote during the exercise and the possible answer. For example, here in a possible answer, when we wanted to print the head, we just simply said, where is it? 1 second. Possible answer. Yeah. In a possible answer, we just say print the head. Simply, we just say that.
Yeah.
But above, we say like from this row, first row.
Can you show me where do you mean?
Yeah. Here, first row, you see? First row and survey head. We wrote a lot of command, but down in possible answer, we just simply said print df dot head.
Yeah, because I mean here you can, with the printer, you can add as much element as you want to print out. So this is just a nice way to write. Okay, these are the first rows. To give a context about what you are outputting. This is,
you can just say df dot.
Yeah, exactly, because you know. But if I don't know, someone else wants to know, okay, what I output to you is first rows. So I just wrote to you, okay, these are first rows as a text, and then I append, and then I add the command that I want to show.
This n represent what, by the way?
Sorry?
This n represent what?
N means that you make a new line, /n.
Okay.
Yeah.
Okay.
Maybe I refused of code, but yeah.
Thank
Okay,
you.
no, but I can discuss with the other guys.
Okay.
Okay,
Yeah,
cool. Thank you.
Yeah.
Okay.
Yeah, all right.
Because you see that first row, double point, and then go a new line.
Yeah. Also for statistic, also here is the same thing we did. Print statistics, and but downstairs in a possible answer we just said print dot df describe. As you said, and this is to explain more, right?
Yeah, exactly. But you can remove it, or you can write something.
It doesn't make any difference.
No.
Okay, great.
Yep.
All right, thank you.
No worries. Okay, so we can discuss the solution. So one of your colleagues asked me this, what is /n? /n means that you do a new line, basically. It's a way to say, okay, Python, here is statistic, double point, /n means that go to a new line. I can show you with another example. So print. I don't know, my name is Francesco. What do you expect? It's just a print with this text. But what if I put /n here? You have my name is Francesco. So it creates a new line, okay? It's just a way to output better your data, okay? Okay, so we can go to the solution. So I run the cell, and the possible solution is, so you just take the data frame and you apply the function head, describe, and then we select only the column exam score, okay? Do not mistake with brackets type. So you can have circular brackets, square brackets that indicate only this column for this data frame. And then we have the other one, I don't remember the name, but this one. No. Let me see. This one, this is for dictionaries. That is another type of bracket. Okay? Be aware of this. Okay. So any question? Yeah?
When I try to get info, it just give me nothing. It's just right there, none. So what does it exactly mean?
Okay. Let me see. It's info also here. Let me see why info doesn't work. I need to check it offline with you. Maybe we can, and then we can discuss it because I need to check it. Why?
Okay, swing. Okay. Okay, so we can go back to the slides, and then we go with the third section of this day. So we are now discussing about file handling and CSV format. So CSV format is something that I have already briefly explained to you, but I can go a bit deeper. So file, what is a file? A file is a data structure that where you can save data inside your disk. So a file, just to be super clear, has a name, dot, and extension. Okay? This extension, what does it represent? This extension represents what kind of data there are inside this file. So for a computer, a file is just a set of 0, 1. It's nothing else. But when you add at the end a file extension, you tell the program how to read this data and how to make it readable to you. Okay? So if, for example, I have an image.png, that means that when I open this image, the program knows how to read this kind of data, okay, in a way that I can show you how the image is. Okay, the same go for, I don't know, txt, that is a way to save plain text, very basic text. The same is for doc. For example, doc is not just text that you see on Word, but it's a composition of formatting, images, stuff like that. And so the programs has to know how to read correctly the file. And this is done by the extension. Okay? Good. So in research, usually you work with extensions that are CSV, JSON, and TXT. Maybe there are other ones, but just for today, I just want to be focused on CSV then. But let's go one by one. So CSV is similar to Excel. So you already know Excel. Excel is a spreadsheet, is a data set. We can call it now data set, where you have rows and columns. So CSV is the same, but the structure is a bit different for the machine. So you don't know to remember how it is inside because the machine do the rest for you, but just to be aware that it's not similar to Excel. It's another format, but it's well used. So if you download, for example, a dataset from internet that has a .csv, it means that it is like a data frame or a dataset with row and columns. The same goes for JSON that would probably see tomorrow for the API calling. It's just a dictionary. It's a dictionary well constructed, well defined, and it can be easily read by the machine, and this is .json. So it means that this file has to be read as a dictionary or a list. And then we have, for example, txt, where you have plain text to save, I don't know, transcript docs. But, I mean, it's not structured because you have just plain text. You don't know what are the relationship between the variables, stuff like that. So if you have, for example, a CSV, you know that you have rows, you have columns, you have the name of each column, you have a structure that you can inspect, that you can use, and it is predictable. So you know what is the structure inside and how to interact with it, okay? A tip that I want to give you is, please do not save files with the white space, because machines go crazy otherwise. Use underscore, because when you do advanced stuff with Python or with other programming computing, using the white space could create lots of problems to you because the computer can interpret it as a different, I don't know, file path or file name. Okay. So please, when you save a file, use the underscore. Okay, so now we will focus on CSV for today. And now the question, how can I find datasets for my research, for my project work? So there are many hubs, there are many repositories that you can use to get data. You can use, for example, Kaggle, Hugging Face, that is one for like deep learning and machine learning stuff. It's very popular. Then this site that I found, they have a bunch of tools and dataset for social science, and then your own dataset that you will see tomorrow. So how to collect data from internet by scraping it. For example, YouTube, Blue Sky, because Twitter has you have to pay to get data. But Reddit, for example, you will see it tomorrow. So now I want to focus you on Kaggle and Pew Research Center, because datasets from Hugging Face is used in the later sessions of the 4 and 5 day, I think. So just to have a walkthrough with you, we can open Kaggle. So this is the interface. It's basically a collection of datasets that people upload online. You can do also your own dataset. You can, when, I don't know, you do a research and you want to publish a paper or you want to publish an article and you want to release the dataset to the community, you can upload it here in order for the community to get your data and to work on it. So, I don't know, you can search for any kind of dataset. For example, the datasets that I showed you before that I have uploaded to you, you can just search for, I don't know, social science. And here you say, okay, I'm interested, I don't know, you want to explore the about, sorry? You want to explore, for example, the about of the dataset. So these are datasets uploaded from other people of your community or people that, I don't know, they scrape data, they collect data somewhere else and they want to share with people, okay? And here you can also see like how the dataset is. It's like doing a describe operation. So you see how the tables are, the total rows, stuff like that. And yeah, this is, for example, one dataset. We can, I don't know, search for BBC News. You can also check like the upvote. That means that the dataset is validated by the community, so it's fine. So for example, this is a dataset of title, publication date, link, description of different news. And here you can have like statistics of the dataset. The one that I is the same function basically that you have saw with me. So yeah, you can have a look at the dataset before downloading it. Okay. To use the dataset, you can simply download it by press this button here and download the dataset as zip. That means that the dataset is downloaded on your machine, and then you can use it on your machine, you can share it with your colleagues, you can open it, and then you can also upload it to Google Colab, that same operation that I have done, that you have done to upload a set of datasets that I give to you. It's the same operation. So when you download something from internet, you need to upload it to Google Colab, because otherwise the machine doesn't know which kind of data to operate on, okay? probably you have to log in to download the dataset. But for example, just for the test, we can download the dataset, and yeah, we already have the zip with the BBC News. You see CSV. That is the file that the extension file that I showed you before. So it's very common to see CSV instead of Excel as something from Excel. And you see that it is basically a dataset. So the dataset with the column, with the title on top, and then all the rows. So all the information that I have collected, okay? This can be, for example, if you don't want news, you want, I don't know, social science, like the one from student, seems fine. Let's see. Dataset. I don't know, social World Happiness Report. Okay? You can download it, open it. And here you see, for example, the guy, the user uploaded multiple years. So you have a bunch of data that you can use for your research. Okay? And if we open the dataset, I just opened this with my computer, but then we will see how to open it in Python and how to operate it after the launch. But this is the general idea that I want to give you, especially for your project work that you have to do, and how to retrieve data easily. So for example, here you have a bunch of information about the country, the region. So the first line is always the name of the column, okay? So you see country, region, happiness score, and stuff like that. So imagine that this is really huge, okay, compared to what we have done before. So if you take, for example, BBC, I think it's like 4,000 row. It's so big that, let me see.
Is it reliable?
Yeah.
So if I say I took this data from Kaggle.
Sorry?
I took this data from Kaggle, not from BBC. It's reliable.
Everyone is uploading.
Yeah, it's personal upload.
Yeah, a person uploading, yeah. So, I mean, you mean for virus or like malicious?
No. Writing an article,
I mean, as long as it's online and you do research and you don't monetize it on it, I think it's fine.
Do they have the code? Do they have the code? How they have coded?
No, I mean, maybe no. You have the license here. You can check the license. But usually, if you do like research, they don't. I mean, as far as I know, if you don't use it for selling for profit, it's fine.
I think what is meant is it trustful? Can you trust the data?
Reliable data and is it trustable?
I mean, you need to go. You need to read a bit about the dataset because you need to know what is the content, what is the what are the the columns, the information that they give you. Like for example, if they have done a pre-processing themselves. So for example, if they remove, I don't know, sensitive information of people. For example, if you scrape from Reddit and you want to release the dataset, maybe for privacy reason, you remove the username and you change it with, I don't know, something else, just to preserve privacy. But usually people should write this. So if they want to upload something to the community, they should also give you all the information, yeah, to reproduce it. Let me see. Okay, so if we check BBC News, it's for 40,000 columns. So imagine doing this manually. With pandas, you can import with one line all this, and then you can create all the description that you want. You can do operation on columns without doing it manually and with just small typing code. Okay, but we will see this after the launch. Yeah, about the reliability, I mean, what I usually do is you have the upvote of people, so you usually see if the dataset has been already used by someone else.
Social science are more sensitive than programming. That's why you focus more on reliability.
I just give you I mean, this is like gold. I don't know what does it mean, but I think maybe something related to Kaggle moderator that gives like score. Let me see. I cannot see it. But yeah, I mean, there is also discussions. Maybe people have, I don't know, concern about kind of data. So you can have a look at it. I mean, I think it's fun and useful to also to practice, because you know you need data, and if you want data, you need to pay people.
How do you know that this data has not been used or like published in terms of articles?
Sorry?
How you can know that this data has been used by someone and published?
So you mean like a link between the paper and dataset?
Yeah.
Let me see. I think. I don't know if it is tracked on this. I don't think so. Here you have the license. You see also viewer people. I don't think there is like a connection between paper, ID, and...
No, but for example, you're working on a data set in specific field. And let's say that I'm right now looking at chatbots' impact on university learning.
Sorry, can you repeat? Sorry.
There's a data about chatbots' impact on university learning. I'm interested, for example, work on it. But how will I know that this data has not been used or published?
No, I mean, usually these data are part of they are released based on a work. So usually, when you publish, for example, a paper, you should release the code, you should release how you made the experiment, in order to be reproducible, trustable, and I mean.
So basically, we are trying to reproduce it.
Yeah, exactly. So I don't know if. So.
To his question is,
Yeah.
Before clicking, there is a name upvote. It shows that how many people approved that data set.
Ah, you mean that? So if the upvote is a meaning of like papers, or you mean this?
Whether people use it or not.
Check if someone has already used it for article purposes. You have to Google it.
Yeah, that's what I'm trying to like find. If I'm using data from any of these data sources, like.
This is a raw data. You can reproduce it for many purposes. If someone has studied it for one team, you can study it for another team.
Okay.
Yeah.
Okay. Now maybe you can Google it, as Sumei said.
You Google it and see.
And you see, I don't know, maybe paper.
Article or Google Scholar.
Yeah, exactly. You have to do, I think, your own research, and like people that uses this data set.
Well, at least author of the article must acknowledge that they use the data set.
And before going to the canteen, I would like to show you this few research. That I don't know if it is interesting to you, but I mean, because I'm not a social science guy, so I just wanted to share with you. We can click on Turkey and see. This is like international question research. Yeah. So you have a bunch of studies, view data. So I think these are like surveys from people. Like we can see data. Okay, maybe this data set is not so big. we can check it. Download the dataset. I think you have also to log into this. I'm just looking at a random dataset. Let me see.
This is a resource center and the team is uploading the data, right?
I think so. I didn't go too deep into this. But I mean, as long as...
They have experts, they have a code book.
Yeah, I think so, yeah. I mean, I found this interesting, so I just shared with you. Okay, so see you after the lunch. Sorry? Okay, so I think we can start. All right, so just a brief recap of what we have done in the previous in the morning. So we saw how pandas can handle datasets for us, how to manipulate them, how to create like a dataset with our own data, with just small examples. Now, before I saw to you how to like find datasets, I know that people like argue about ethics, so I didn't know this kind of thing. But I mean, just for project purposes, I think it's fine for you to use this, because otherwise I don't know if you where to take data. So I think this is the easiest way to you to practice with pandas to have to hands-on on this kind of functions. So this is the general idea. Now we move to a hands-on applied workflow. So what we want to do is to actually use this data that we have downloaded, or like a colleague gives to us, or something like this, and then analyze the dataset, make some changes, and then save back. Because when we make changes to a dataset, or like a spreadsheet or a data frame that we saw, we need also to save it. Because otherwise, if we don't save the new created dataset and the changes, we lose the information. So I will show you step by step how to do it. And okay, so the important thing is that you have, again, Google Colab open with the notebook of today. The section is applied workflow. And I hope that nobody like disconnect from the cloud source. Otherwise, you need to re-download the assets file and re-upload it. So I just show you what you should find. So if you open this icon here on the Google Colab, you should see like 4 files. If you don't see them, please raise your hand. Okay? Okay, you just need to re-upload the data, but I can just 1 minute. Okay, now upload. Great.
I'll do it.
Okay, great. That's nice. Anyone else?
I uploaded the data, it was fine, but now I have different files here.
Okay, yeah, because you have, I think, uploaded your own, the file of your computer.
Okay.
Try
I'll
to
upload again?
Yeah, try to upload again. The same procedure that we have done before.
I can do that, thank you.
Yeah.
Here, right?
Yeah, cool. Yeah, that works. Anything else? Anyone else? Okay, nice. Is it fine? Works?
It's uploading.
Cool.
Yeah.
Good. Okay, so now it's time to use this data. So we can use it. Oh my God. Sorry. Let me see. can fix it. Yeah. Okay. So now, what are these datasets? These datasets that I provide to you are basically datasets that I downloaded from Kaggle. So, like the BBC News is the one that we saw before the lunch. So it's a dataset of news with some columns. This small news dataset is a sub dataset, a sub selection of this dataset, because this BBC News is very huge. So in order to practice a bit on it, I just made a small version of it. Student social media is another real dataset downloaded from Kaggle. And this happiness survey 2015 is just an example on on how to convert an Excel file to a CSV file. So the difference is, we saw before that usually you have files that are on .csv as extension, but you can also find files. If you use Excel, for example, you will see the extension is XLSX. So this is not bad, but pandas have difficulties to work with this data. So it's better that you convert this file into a CSV file. I will show you, it's pretty easy. So this is done just because, pandas works well with CSV. Okay, so I think now it's clear where the data comes, okay? Now we are working on this data, not anymore on our own data. So when you upload the data on the machine, on the remote machine, you can investigate it, you can open it. So if you double click on it, you can see a small window where you can have a check on the data frame. So the data frame has a bunch of columns and a bunch of lines. It's like having a dot head, so you see just the first 10 rows in this case. So you just see what is happening in your dataset. Okay, so we can move to the applied workflow section. So this is what I said to you. So moving from Excel to CSV is preferable because CSV is plain text. As I said, is more efficient, and also it has a syntax that is easier for the program to work. You don't need to write CSV files because you just convert it. If you have an Excel file and you want to make it in a CSV file, it's fine. You don't need to worry about this process. But the important thing is that you have it. You convert the file in CSV, okay? Okay, another thing about CSV is that it does not support multiple spreadsheets inside. So if you have, for example, Excel, you can create multiple spreadsheets inside the one, I don't know the exact name in English, but I think it's sheet. This does not work with CSV. So every sheet is a CSV file, 1, 2, 3, 4. So if you export, for example, an Excel, and you have multiple sheets, you should treat it differently, but I will not discuss it here. It's just for you to know that this is not, you don't expect to have multiple sheets inside the CSV. Okay, so this part we have already done it. So we have uploaded our data on the cloud machine because we need to work on that machine. And so if you want to convert the Excel to CSV, you just do this. You just import pandas as PD. So you just import the library with an alias. You set a path. What is a path? A path is a, how can I say? It's a directory. It's a path.
File is located.
Yeah, exactly. It's where the file is located inside our machine. To access this kind of information, you just right-click on the file, and you see copy path. So you just copied it, and then you have in your clipboard, so if you go Command V or Control V, you will have it at your disposition, okay? So I just copied it. I have already done it for you, but we can do it again. This is just, okay, so I missed the file. This one. So you see that based on what you are copying, you have different version. Okay, so what does these two variables do? So basically, it is a variable that contains the path to the file. Okay, and this is the path where we want to save the Excel converted. So it can be any. Notice that I use always the underscore, because it's really important to not use white spaces while you save files, okay? So basically what we do is to convert an Excel to a CSV. We simply read the Excel, we save it in a variable, in a data frame, and then we use that data frame dot to CSV. That is a function that converts our data frame to a CSV, okay? Index equal to false is used because otherwise you have an extra column that represents the indexes that is not useful because we use the row. So take it as it is, it's fine, okay? This is, this is really important because with this line you can do a lot of stuff. You can convert an Excel to a CSV, or you can simply, I don't know, take a data frame, whenever which one, you create a data set, you want to save it, you just take the data frame dot to CSV and the variable that contains the path, okay? So by doing this, you are saving the CSV file inside this file, okay? Important is that you have the path, so the CSV path should be should ending with the correct extension. Otherwise, you have the program when, for example, you want to upload again in your computer, and you want to upload again on Pandas, you should have the right extension of the file. Okay, so if we run the cell, we see that our file has been saved as a CSV to this content, okay? Slash content is basically this window here. And let me see, okay, so if you run the cell and you don't see already the file, you can just reload the file system. And this refresh basically what you have in your machine, okay? And you should see like my Excel converted. And if you open it, you should have your Excel converted to a CSV, okay?
What does false here mean?
Sorry?
Index false.
Index false means that because when you have a data frame, you have always like an index at the beginning that represents where the data are. But since we are converting it to a CSV, we don't need that because CSV takes care of it. So we don't need to add an extra, like an extra column to say, okay, this is the index 0, 1, 2, 3, 4, 5, 6. So we don't need it. This is just thing that you can take as it is. You don't need to change that parameter.
So we don't say numbers, we use words.
Here?
Yeah, instead of 0, for example.
No, I mean, index is just to represent which row is, so you enumerate basically the rows of your spreadsheet, of your data frame. But you don't want to report it in your CSV because it's extra information that you don't want.
And if I want to add an extra?
An extra what?
I say true instead of false?
You have, basically, we can change it. this one, you see that now you have an extra column that represents basically your role, but it doesn't give you any information. So it's not useful. It's just an extra column that brings you no information. So that's why usually you skip it. Okay? Thank you. So if we remove it, we have a clean data set.
Can you tell us again how did you get these four sample files within this files column?
This one, you mean? This is CSV? You mean like BBC News? How?
I know it's in the Google Drive that was shared.
Yeah.
How do I get it into the column?
Okay, so to get to the column, you need to download first the assets. So you have this link, right? Are you?
Yes, I have the link. I downloaded it to my desktop.
Perfect. Then you open it and you should unzip it. I can come here. Like to expand, for example, a column, to expand some details, to have like summaries, to translate, I don't know, titles or descriptions. So, for example, you have a scenario where you run a survey and you have 300 people that reply with a text answer. For example, they reply about how good is Istanbul, okay? Then the goal is to extract the main concept of these collected data sets, text. So for example, you want to, I don't know, generate a title, you want to generate a tag, you want to generate a bullet point with summarization, for example. The problem is that you cannot do it manually because it's time consuming. It costs you a lot of human effort. So you need a way to somewhat automate this kind of thing. So the solution, one of the solutions, is to use LLMs to generate for you. So how we can use LLMs in our workflow? So for example, I think I don't have slides, okay? We can see it in the column. So how we can integrate LLMs in our pipeline? There is this fantastic library in Google Colab that is called Google Colab AI. It's another library, it's like Pandas, but built just for using Gemini inside your Google Colab. And this is also, there is also Open Router, that is a site that offers a lot of models, but this is advanced, it's just for you to know that it exists. And then I just put it just to spark curiosity. Open Router gives you the possibility to use a lot of model. Closed model means that like GPT or Gemini or Claude are closed model because you cannot access their weights, so the model you cannot download in your machine and use it. You need to pay them to get data back. But yeah, I mean, if you want to know more, we can talk it later. We will now just focus on Google Colab because it's the built-in library for in Google Colab. So I wanted to give you just a list of on how to prompt well when you want to ask help for like to models. So if you have a general input, you will have a general output. So when you ask to solve a problem to an LLM, be precise with what you want. So you need to add details because they need context. They need something. They need to know what you want. So be specific. If you ask just to, I don't know, analyze this data, LLMs doesn't know what you want, right? So you need to be specific, like analyze this data in order to understand how people react to this message, for example. So you need to be very specific. And one other tip is to focus on a single well-defined goal. Do not try to like resolve everything in one prompt, but just try to think and to prompt your model with a specific goal in mind, and in case, create a new chat or use another prompt. Only include the relevant context. So if you have a chat in your ChatGPT or Gemini, usually you should have only relevant context about your goal, about your task. And if the model is lost or it outputs something that is not what you are expecting, maybe it's better to review the context or to restart and then specify it better. Be direct with imperative verbs. So don't say to the model, please, or thank you. That doesn't help. So it's just because we treat it as human, but it's not human, it's a machine. So be direct. And current state-of-the-art models like Gemini, Claude, ChatGPT are very strong at instruction following. That means that if you ask an output that should be in that, I don't know, you want the output to be exactly a list, or you want the output to be exactly a dictionary, you have to specify it, and the model for sure will follow it. So if you are very specific with the request, the model will 99% of the time be very good at reply to you. Okay, so this is just some tips. We can have an hands-on on this LLM. This is the last hands-on of today. So we can move on again to the Google Colab. And this is the last part. Okay. So I just expand it. Okay. So Google Colab, so to use the Gemini inside your loop, inside your workflow, you need first of all to import the Google Colab library. This is a new syntax maybe for you, but it's just from a specific library, import just this, okay? So nothing difficult. It's just that you are importing something from an amount of function of a library. So you want exactly this function. Here you can print the list models. So you can print the model available to you. And if I run it, I will see that I have Google Gemini Flash and Flashlight. These are like low-cost model, but I think it's fine for what we have to do now. I think that for pro models, you need to pay extra thing, but I mean, I think Flash and Flashlight is fine for you. So how we can query Gemini to have a response? We import again the model, and we create a new variable. This variable will contain the output of this question. So what we do is we use the variable .generate text. So we query, we send to Gemini a request, and we ask, what is the capital of Italy? It's like writing it on Gemini, so on your Gemini portal, but you are doing programmatically. So if I run it, I see that it replies with, with the capital of Italy is Rome. We can just change this to, I don't know, Germany. So every time you have, basically your model, you are interrogate the model Gemini to give an answer back. Okay, so a use case for like a newspaper. So we have a news to summarize. So I just take this news from this website. I just copy and paste the content of the news, and this is a bit different of what you saw before as a string, but basically with this, how can I say, not brackets, but quotation, thank you, quotation, you are basically say, okay, Python, from here to here, it's only text, so consider only text, right? This is a way to like stack multiple paragraphs together and avoid that Python misinterpreted it as like variables or stuff like that. So from here to here, this is text. This is like a description of the news. Okay, then you usually, now we have to ask to the model to summarize the key themes of this post. So I want to create like a bullet points, 5 bullets, and this is the output that I am expecting. So based on this news, I want an output of 5 bullet point. So how to do it? We need to prepare the prompt. The prompt, so I say, okay, I give it a role to the model. You are a research assistant. Summarize the key themes in the post, bullet point, 5 bullets. This is the post. This is the same syntax that we saw at the beginning, where you put in brackets the variable. This variable is essentially this one, and when you run it, it basically takes this whole text and it puts it here. Okay, so the final prompt would be, you are a research scientist, summarize the key, post. Maybe post is not, I mean, it's just one, so you can just use post. And then it automatically changes this variable with this. Okay?
What is the F before?
The F, correct? F is the same that we saw at the beginning, where if you want to interpret these brackets as a variable and not a text, you need to say, okay, pay attention that I give you also a variable, and so you need to use F to tell the Python, to Python, that you are putting a variable. Otherwise, if you remove it, it will consider it as a text. If you see, it changes color. You see? And this is like, okay, I prompt the model this, news to summarize. He doesn't know anything about this. But with S, I replace the variable here with the one that I specify here. So then I run the response again with the same syntax that we saw before. So AI.generate text, prompt.strip. Strip because we want clean output. So we want to remove left and right spaces if the model generates something. But this is just a way to clean the output of the model. Nothing special. So if we run it, it will take a while. So what happened? It sends the prompt to Gemini, to Google, and then Google reply to us. And this is basically the response of our model. Okay. Here are the key themes of the post, blah, blah, blah. Okay? I want to make it, I don't know, summarize again in this post, be concise. Okay? I expect that the message is a bit shorter. Let me see. Not too much. I don't know, we can change. I have another example. Done. Okay, so far, is it logic, the way we are using this? Good.
Can you ask it to,
Worry.
can you ask it to figure out particular words rather than
summarizing the key themes, find particular words for me in this text.
You mean like?
Let's find how many times is Hong Kong mentioned.
So you mean like ask, is there a Kong here inside this this post? How many times? I mean, models like LLMs are not very good at counting words. So yeah, they can do lots of stuff like summarizing, translating, like expand tasks, reduce them. Counting is not, as far as I know, they are not very, they are unpredictable. Yeah.
But what about thematic analysis?
Sorry?
Thematic analysis, for example, from the paradigm.
Sorry, I didn't understand.
You are going to do a thematic analysis, themes coming out.
Yes.
Are they good at it or no?
I think if you use like small prompts, I think yes. I mean, we are using Flash, so it's like the base model that you can have. But I think for this kind of, I mean, you can run like 3-4 posts and then see if it is suitable and it's good for you. But
for example, if in qualitative analysis, there's a Brown and Clark thematic analysis, very famous. So can we, like, for example, give that specific prompt kind, like, I want this, for example, background?
Yeah.
Use it.
Yeah, I mean, the point is that you need to try if it works with your setting. I think, yeah, the best way to answer this is you try, you see if it works for your setting, and then you decide if you want to upgrade, if you want to change model, if you are satisfied with it. So, yeah. I mean, I think I didn't read it, so, but I think that with current models we can have sort of precise. If we ask, for example, for summarization, for translation, if we ask for like counting, stuff like that, I'm not really.
Counting is basically coding, same way, thematic analysis.
Coding?
You're like, per theme you are giving codes. And if, how many times, or like, what are the major themes based on those codes coming out?
Okay.
For example, you're mentioning Hong Kong here. Hong Kong isn't a country, you code it like isn't a one, and then asking. That's how thematic and manually we used to do.
Yeah. I mean, I didn't get well the observation.
The thing is, they are more concerned, I think, with quantitative instead of computer science. These methodologies are maybe a little bit more concerned to us. So you basically need knowing more than him about it. So you need to try it. That's the thing. You need to test it. You need to test whether Gemini is doing good in thematic analysis or not. Because my experience with it doesn't do it as good as special software that does it.
Sorry?
What's thematic analysis?
Thematic.
I think it does it better than Gemini.
That's why you don't understand. That's kind of the way we work with this data.
Ah, okay.
Not for the numbers.
Okay.
We give them some kind of codes like the names, so that we understand data categorizations. For example, the emotions, positive. Negative.
Okay. They're not good at it?
No, I don't. This can work on that, but he was like trying to understand if we can use this in that way.
Ah, okay.
Since you don't know the thematic analysis, you didn't maybe understand the question.
Okay, thank you. I mean, I don't know exactly the answer, but I wanted just to show you that you have this possibility, like for translation for, yeah. I think that, so at the end of these days, you will like rely on AI-based system. So I think that, yeah, you need to, I don't know. I don't have the answer, sorry. So, yeah. Okay, so just a quick tip. So you saw that we have here as the key themes from the post. We don't want this kind of introduction, because we want like plain text without having more additional information. So basically what we can do is just say to the model, okay, we don't need an explanation initially, so just return the bullet points. So what happened is that I run again the command, and I just have, again, I don't have like an introduction, but I just have my information that I ask to the model. So I ask to the model just the bullet points. The same can be applied to the first example. Sorry?
It's not a question, actually. There's some confusion for me because I'm working with really large data and working with researchers. In each case, what I got, the answer is completely different from yours. So basically, sometimes the word is really meaningful for us.
Okay.
Because for me, it says Hong Kong is a significant hub for foreign talent. However, in this case, Hong Kong attracts a significant number of foreign professionals. So basically, is there any way to standardize? Because we are not working like singly, but sometimes we are.
You need for like a reproducibility to be like. With closed model, you cannot. So it's called seed. So you basically set a seed to the model that like freeze the way like random stuff work inside the model, because there are some random like weights and some part of the model that can change at runtime when you ask. This is not possible with closed model. So like ChatGPT, Gemini, Claude, you cannot fix the seed. But with open model that you will see, you can fix it just for reproducibility. This is, if I answer your question.
Can it be a trend, the browser or the person who is using it, based on that the model is responding?
So you mean that...
For example, you had put it, we clicked the same, it's giving very different response.
Okay. I mean, this is not something that we can control.
I mean, like, for example, is it influenced by that way?
No, I don't think it's... No, I don't think they rely on your like context of like your Gemini chat done before. It's just a model. I mean, they don't rely on this kind of information. As far as I know, they don't use your memories or extra context. Yeah. Okay. Okay, the same is done for the capital of Italy, where we have no explanation. So we have just Rome. So what I was thinking about, but now I see that there are concerns about this. I mean, what I was thinking about is that you can use LLMs to summarize, to classify text, to extract some type of topic, to translate, to enrich something. You can do basically what you are doing with ChatGPT or Gemini with the web browser inside Python. I mean, yeah, this is just for like show you that you can use this library. But yeah, I mean, you have to test it based on your task. Yeah. So I think this is the main concern of today that rise, right? So how is applied to my task, if it is reliable or not, right? So yeah, I think you should try it and see if it is something that it works for you. So let's apply this to a real data set. We just load the small news dataset, that is the one that you saw in your file system. The small dataset, if we open it, is just a small portion of the BBC News. So I've truncated it just for this presentation and for this Google Lab. And what we do now is just load the dataset as we have done before. So we just load the CSV path, so the small news dataset.csv. we read it, and then we print the shape, the column, and the full data set. Okay? So let's run the... And then, yeah, we have the same statistic that we saw for all the day. So the shape, the column, and stuff like that. Okay, so inside small news data frame, now we have our CSV file. So we can use this data frame to like add new columns, remove columns, do manipulation on it. So, for example, I want to translate a specific column. So, for example, if we see the, so let me see the full data set. So if we print the full data set, we have the column title, publication date, guide, link, and description. So what I want to do now is to translate this description in another language. And what you can do is to automate this by using a pipeline with the LLMs. So what you do is you create a new empty column. So we create an empty column called description translate. And then you iterate, you use this for loop for each row. So maybe here is easier. So for each row of my dataset, I want to take the value inside the description and then make a translation of it. So this is exactly what this code do. This is a bit, I mean, it's the end, so I know you are tired, and this is a bit advanced, but I mean, this basically what it said is, okay, for each element of my row, take the value inside the description. So I created a prompt in this way. So you are a professional translator, translate the following text to Turkish, return only the translation. And this is the text that we append. So what we are doing here, since it is a loop, we loop for each row. So in this row here, we loop for each row, and then we take for each loop, we take the description of this data frame. Then we prompt the model to generate the text for us, and then we add the response to the description column translation. So if we run it, it will take a while because it's like 4 prompts to do. Okay, and you should have like a translation one by one about your row. So you can translate descriptions in different languages by just saying what you want to translate in which language. Then you want to save again this file. So the data frame is in your computer. So we want to save the CSV with this new column. So what we do is to create a new file, .csv, with a new file name, and then we save it in a CSV file. So if we run it, again, we have our new CSV file. And at the end of this column, we have the translation of the column that we have. Okay? Okay, if you want to try yourself, maybe I can skip this, and maybe if you want, we can do it later. I just want to show you. No, I think we have done it. Okay, so it's finished the notebook. You can try it yourself by just summarize the description in keys and like doing basically the same pipeline that we have done it, but just changing the prompt by doing something else, like summarizing or stuff like that. Okay, just some tips. I don't encourage you to do this on large-scale dataset. So, for example, if you have 40,000 row, I mean, you could reach like a limit because you have like free calling to the Gemini, I think per minute also, but I don't know exactly the values. So be aware that you cannot scale with a lot with this with the current limits of Gemini. Today we saw just that you can use this tool and what you can do with this tool. Keep the prompt small and precise on one goal, as we said before. And yeah, save always the file, the CSV file. And also remember to download it because otherwise you don't have it in your machine and you lost it after a while. Okay, so I think for today we have done it. I would like to, I think I have another slide, yeah. I would like to do like a mini social science data pipeline that you can try yourself and just apply what we have done today. So just load the dataset, inspect the dataset, remove the column that we don't know, that we don't need, like the link and the good, and then save again the clean dataset. This is a practical way to apply what we have saw today. So if you have questions or other thing, I'm around. I mean, you can try by yourself. Yeah, please. Okay. Okay. So if you have your questions, I mean, I'm going around. You can try yourself to load this BBC News. That is the one that you already find inside your machine, and load it and see how to manage this data frame.